Tanya is a professor and the director of the Translational Data Analytics Institute at the Ohio State University. She's also a founding member and project lead for WildBook, an open source platform which supports the use of AI, computer vision, and citizen science to advance wildlife research. We've invited Tanya here to share her insights as a founder of the field of computational ecology, working at a unique intersection of disciplines and across sectors to create solutions that address questions at the forefront of movement ecology. So Tanya, do you want to take it away?
Thank you. Thank you for inviting me here and being part of this conversation, and for hosting this conversation. So Martin, that's a tough act to follow. Thank you for kind of great overview and of the future. And Christian, thank you for even more succinct hitting all the points. So with that, I want to acknowledge the current funders, main funders also of our projects. That's U.S. National Science Foundation, and for most of my research, and Gordon Betty Moore Foundation for WildMe nonprofit work. So with that, where are we now? So starting with where we're now and kind of summarizing maybe even in one slide. So we recently have a paper with many authors, but led by Davis Tue, Ben Kallenberger, and Sarah Beery on and many others, really this kind of survey on machine learning for wildlife conservation. So, you know, the data sources, as was already pointed out, the type of technology that is now used to collect data is growing, has grown exponentially and truly exponentially. I mean, it's multiplying every few months. The type of, not only the type of technology, but also the within each type, you know, the type of drones that are used, the type of data that's collected from drones, you know, the types of sensors, on-body sensors, the environmental sensors, and so on. And increasingly, yes, community science with images and labels. The data analysis also is, you know, the tools are progressing. So basic data analysis, sort of not even the inference, but computer vision tools have grown over the last 5 years massively. This is with the collection of big data sets led by, and the tool development led very much by the big tech companies. And then the kind of tasks that are now possible in the wild from even the images that we have are the, you know, everything from very fine grain kind of pose estimation and, you know, down to ears forward without even a lot of tagging, kind of de novo, to species classification, individual ID, environmental reconstruction, and so on. A lot of work on tracking also comes from, and it's been mentioned in previous sessions as well, also comes from developments in human tracking. And again, many sort of tools and methods that can track in unannotated, unprocessed almost videos and series sequences of images. So this is from video. And then there's a lot of recent developments also in time series analysis and machine learning for time series analysis. Much of it is coming from and used in the environmental and movement ecological settings, but comes from even applications like financial fintech and market forecasting. So the one thing has been mentioned also is the aggregation and the connection among these technologies. So maybe we have enough data, as Martin said, although I would very vigorously dispute that, because we have good coverage in some places for some species, for some contexts, but very poor coverage for others. I mean, the fact that you know, IUCN Red List still the conservation status of killer whales is data deficient, tells us that we probably don't have enough data for things that we want to have. And but there are platforms now, including MoveBank and of course eBird, iNaturalist, and Wildlife Insights. This is mostly for data aggregation, and then some of them also include analysis and communities. Also ours, Wildbook, which is the project of WildMe, and then WildLabs and AI for Earth are platforms for tools and community connections and aggregation. So given all of this, what's next? What is like really on the cusp of, if we put, as we said, if we put just enough resources, we can almost brute force it. So a lot of that comes of what's next, in my opinion. First of all, it comes from transferring, as it often happens in this field, tools that are developed for human context and for human applications, for tracking humans, for analyzing human behavior, movement, and so on, to adapting them to the context of wildlife biology. And then the other aspect is what is brute forceable is, getting enough data, because this is, the technology here is very much data driven. And so I think in terms of what's next, we've done a lot in the video data analysis and computer vision. And we now have workshops like computer vision for animals in the upcoming major computer vision conference. But the acoustic data analysis is really lacking, and including for movement. And there's a recent paper in Trends in Ecology and Evolution that shows that really, for marine species especially, but also for avian, for birds, acoustic data can be a major source of tracking animals, non-invasively especially, and at much larger scale and higher resolution. The other part, what's next, is what we've done a lot with image data, single data, but we haven't really taken advantage of video data. And there's increasingly video data that's available. And the way that's right now, most of the video data is analyzed and used is essentially broken down into frames. Well, that loses a lot of information. And so we're like really on the cusp of the first methods of really taking full advantage of video data. And I think once we really can do this, once we take full advantage of video data, there's a lot more information, not only on movement and tracking, but also the context and the social context. And so the paper that's shown here and the work that's shown here is specifically using kind of very unsupervised tracking from videos of animals in social context. But there's many other kind of coming up, and again, many of them come from human video analysis work that are being adapted to animal work. The part that's been mentioned both by Christian and Martin is what's really coming up is both intelligent tracking, so increasingly making the tags that are on body tracks, the sensors, intelligent, putting the computation on the tag itself, whether and also non-invasive intelligent tracking, whether it's using multiple UAVs. So this is again a lot of the technology from using UAV swarms, small, relatively quiet, multiple viewpoints, used quite a bit now for search and rescue, with longer and longer battery lives and recharging with different ways, so they can continuously fly as a swarm, and starting to use them for animal tracking and inferring information directly from video on the fly with the computing on board. And I think, this combination of non-invasive, whether it's acoustic trackers, drones, or camera traps, or other devices, both the something that can adaptively follow the animals and put the computing on board, as well as the crowdsourcing and citizen science and community participatory approaches, that, again, in some ways, there are sensors that follow the animals and have computing on board and can produce answers adaptively. So we have it's not a paper, it's a quadrennial report of the Computing Community Consortium, which is the essentially think tank of the Computing Research Association, main academic research organization that we just put out as a briefing on AI and citizen science, AI and computational research. So the opportunities, particularly in these kinds of applications of wildlife biology and conservation. And also the non-invasive intelligent tracking is really driven by our ability to do this fine-grained classification, increasingly using biometrics for re-identification, which is the work that we've done a lot, and but also using individual identification and tracking from acoustic data from in the water and as well as in the air. And so I think this is where really on the cusp of a completely different way of getting data about animal movement. The other big thing, as Martin pointed out, is we it's not enough to have all this data, whether it's tropical ecology, avian ecology, for this species in isolation or that species in isolation, sometimes in the same region. We need to start integrating both the data and the workflows. And so Martin showed a great example of that. We need to do it at much larger scale because, to quote, right, nothing makes sense except in the context of environment and evolution. So we need to put all of those data in the context of environment at the very least, and all the and other species that are there. And so all these platforms that are that are being developed, they're also relatively siloed and kind of bespoke and specialized, whether they specialize, on a set of species like eBird, or the type of data like MoveBank, or the type of analysis like WildBook, which is specializing in individual ID, or the type of community like iNaturalist. So we need to start integrating, and we're starting the work. For example, WildMe and Wildlife Insights we were in conversations about connecting the platforms, so then that you don't have to re-enter data from one platform to another, but the analysis can be used between the platform, and similarly, maybe connecting iNaturalist, eBird, and so on, so we can really start building up these global data sets with global context of multiple species, and that really reflect what is happening out there in the nature. And finally, sort of a very technical, what is also happening until now, we've been building kind of bespoke solutions. Yes, we talk for the cyber infrastructure of for each one of these kind of technology-enabled tracking and analysis efforts and projects. The limiting aspect in many of them is the cyber infrastructure, and the infrastructure in general. Do you have the network, so bandwidth, energy, bandwidth, electricity, compute power? What can you put on the sensor itself? What can you put in the field versus what do you need to really do to just, when do you really need to collect the data and use the server for analysis? And so one of the very recently funded US National Science Foundation's Artificial Intelligence Institute, this is a big kind of project, $20 million, is explicitly an institute for intelligent cyber infrastructure with computational learning in the environment. So this is AI-enabled cyber infrastructure for AI that is creating a seamless plug-and-play kind of environment, cyber infrastructure from edge to server. And one of the applications that they're looking explicitly is animal ecology. So full disclosure, I'm part of this project. So that hopefully is coming in the next couple of years. And that, but it also is, it's a bigger question than what's coming in the next couple of years. So what are the moonshots? And the moonshots, to me, is much bigger scale connection and synthesis, because connecting the existing platforms and the existing data sets still doesn't give us this picture of like all these animals with all the species in the environment as it's happening, right? Down from, and connecting not only data among all the data sets and connecting it adaptively, right? We're leveraging one species to track information about the other, the prey to identify the predator and the poachers, and adapting it to the environmental conditions and so on. But also the technology that connects among people. Some of the platforms like Wildbook and iNaturalist and eBird intentionally build in the technology that intentionally connects among people. At the bottom of each Wildbook page, for example, there's everybody who has contributed data about that specific individual. So that forces kind of, because there's not one project or one organization that has information about one individual animal typically. So we have to share data and we have to connect among people. It also, we need a technology and methodology that it connects scales from individual to populations to species, from local, regional to global planetary context, from local temporal in the matter of seconds, which is what typically GPS and other sensors give us, to long-term monitoring over the life of a animal or a population. And then we need connections among models and methods. We're really at the beginning of this effort on the computational side. How do we properly connect methodologies and models, particularly machine learning models, and yes, the infrastructure, and the very much at the kind of the frontier of research in AI is human-machine partnership. How do we really properly do this? And to me, sort of the moonshots is kind of creating the whole science of extracting biological information from these different kinds of data. And one of the examples is Imageonomics, is another new National Science Foundation Institute in harnessing data revolution to establish this whole new field of Imageonomics, which, like genomics before, extracting information from biological information from sequences, this is extracting biological information from images using biology-guided quantitative computational approaches. Again, this is I'm the director and PI of this effort, and this is a growing community and set of tools, hopefully leading to sort of really truly kind of horizon of explainable AI, where we can tell not only, this is this species, but this is this species because this is this behavior, because we're making this prediction because that leads not only this kind of from descriptive technology, the descriptive analysis, but to use machine learning, AI, and computation to generate hypotheses that then can be tested, because machines see things differently than humans. For example, humans cannot tell you, which of those two pairs of zebras are more similar to each other. We have no way to quantifying similarity of stripe patterns, for example. There are many things that we don't see. There are many behaviors that we're evolutionarily not focusing on, which are meaningful for other species. So can we use computational approaches to extract things that humans may be missing and generate hypotheses that get us away from human biases? And then, of course, all of this has to be in the context of doing no harm. We have to improve, with all of this, we have to improve on existing, including the cost and environmental cost. Technology, all of this technology is energy hungry, rare metals hungry, materials hungry, and water hungry. So, and produces it has huge CO2 footprint. So is it worth it? And we need to worry about the data governance and security, protecting not only the people, but the species, the endangered species information. So in the effort to protect the species, we don't disclose information that can destroy them. And then dealing with the bias, including data bias, and really democratizing science, which has been mentioned several times, so that the access which is happening in AI, that the separation between those who have access and those who do not is becoming more and more and more pronounced. We have to get away from this and ensure that the technology is available to all, and that this technology, we create technology that enables science conservation and public engagement at large scale and high resolution over time, space, and individuals by bringing communities together and working in partnership to provide solutions that people trust. Thank you.
Thank you so much, Tanya. We won't have many questions, but because I'm aware of the time, but your talk has kicked off a big discussion about citizen and community science in the chat. So Paul, I was wondering if you wanted to put your question to Tanya.
Yeah, sure. Hello. So I've noticed the mention of community in all of the talks so far. No doubt they'll appear in all of them. But I'm just, as an online community manager professionally, I've been doing that for 10 plus years, and an amateur naturalist who does participate in citizen science projects, biological recording specifically, but other stuff as well. I'm just wondering, for people who come from an academic background or research background, how big a role does everyone see community citizen science playing a part in the future of movement ecology tools?
Huge role. So first of all, technology allows us not only to enable better kind of traditional citizen science models and frameworks, but also engaging people where they're at. So for example, one of the tiny examples, we built a bot, a intelligent agent, but it's a bot that scours publicly posted, let's say, YouTube videos of animals, and identifies, sends it to like individual ID to Wildbook for the appropriate species, and then posts in the comment, hey, at 2 minutes 46 seconds in this video of your vacation in Mexico, we found this whale shark. Here's everything we know about it, and the link to the appropriate page or Wildbook of that individual. And the response is, oh, wow, this is amazing. We have like more than half of the people engaged. And the biggest question that they pose, the next question to the bot, right? They realize that this is a bot. Some do, some don't. Is like, how can I help, right? So immediately you make it very personal. The technology makes that not only they saw a whale shark somewhere on their Cancun vacation, but it's this specific whale shark. There are others that saw it. It connects them to others who also saw that whale shark. It gives them a little bit of a story and makes it very, very personal. And they didn't even know that they were contributing to science and conservation by going on vacation. Suddenly they do, and they have probably tons of other videos, and they engage. And we actually see that not only that more than half of the sightings come from these online postings, they're distinct. They're the ones that otherwise were not viewed by other by intentional sort of by other citizen scientists or scientists and conservation projects. So this is an example of how technology can engage and connect people that traditionally may not be part of this participation. We also saw from Martin an example where citizen scientists can not only be data contributors, but pose questions and produce analysis. And there are other examples in astronomy of how people can actually pose questions and use tools. Now, technology can enable people to ask these questions and follow through on the answers, right? So they can be part of the conversation, not only labelers, not only taggers, not only data collectors. And I think, and so the paper that we have on citizen science, AI, and computing outlines some of these opportunities where, and not only that, but people can be now policy evaluators, right? And there are examples in UK actually of noise pollution, where people can collect data that is specific to evaluate different proposed policies, and they have both the agency and the ability with the technology to do that, right? So they can be now part of the entire process. And we have also other examples like the Great Grevis Rally, where it is the ordinary people driving around the country taking pictures, but what enables them to contribute to policy and conservation policy is the trust in the process and the fact that they can follow through their piece of data all the way to the final answer that supports the policy.
Wonderful. Okay, there's a question that David has in the chat, Tanya, that I'd love for you to pick up about acoustic tracking specifically. So if you want to pick that up and have a scroll back through all the conversation that's been happening about motivating citizen science, please do so while we hand over to Ran. I'll bring you back in a few minutes.